Hello friends, welcome to my channel Physics with Rakshi. In the present video, we will see last chapter of the book Loop Quantum Gravity for Everyone, authored by Rodolfo Gambini and Jorge Pullin. It is conclusions of this book given by authors of this book. We know that in previous 8 lectures of this series, we show Introduction to Quantum Theory of Gravity in first lecture. Thereafter, we saw general theory of relativity and quantum theory up to relevant extent, which is necessary to describe loop quantum gravity in second and third chapter. In fourth chapter, we show loop quantum gravity, necessary concept of loop quantum gravity for audience who want to know what is loop quantum gravity. Thereafter, fifth and sixth lecture, we saw application of loop quantum gravity, that is black hole and loop quantum cosmology. In the seventh lecture, we saw further developments in the loop quantum gravity community, that is covariant loop quantum gravity or spin form approach. In the eighth chapter of the book, we saw some possible observable consequences of loop quantum gravity. In the present video, we will see conclusions. First of all, author gives us that what is loop quantum gravity in essence. Loop quantum gravity is the combination of mixture of Faraday lines. We know that in loop quantum gravity, Faraday lines are allowed to intersect and pierce. Second concept is spin network of Penrose that I have described. And third, symmetry is diffeomorphism invariance, which makes theory background independent. Thereafter, author emphasized that don't read online blogs and articles which are written by prejudiced people without technicality and mathematics. And authors also suggest some technical research papers and review papers to read so that people can understand criticism of loop quantum gravity and answers given by physicists of loop quantum gravity community. There are some criticisms on loop quantum gravity here. As a frank physicist and transparent physicist who consider transparency in scientific research and methodology, they give some criticisms of loop quantum gravity also with some answers. So first criticism is regarding distance. We know that in loop quantum gravity, we consider Ashtakar-Lewandowski distance, which is important concept. This kind of distance is not considered in rest of quantum theories like quantum electrodynamics, quantum chromodynamics, quantum flavor dynamics, or in short, quantum field theory. They consider traditional distance in quantum field theory. But in loop quantum gravity, traditional distance is failed to deliver more tractable ideas in quantum gravity theories. So, this distance differs from other quantum theories which consider traditional distance, and here traditional distance are failed in loop quantum gravity. So this kind of distance was built with diffeomorphism invariance symmetry that other theory don't have. Diffeomorphism invariance symmetry is the core idea of loop quantum gravity that makes loop quantum gravity background independent. And that is why Carlo Rovelli once told that in loop quantum gravity, loops are one-dimensional object that forming space. Rather, in string theory, strings are one-dimensional object that moving in space. So this is the fundamental difference regarding this criticism. Second criticism is emergence of discrete structures in loop quantum gravity. We know that in special as well as general theory of relativity and in all quantum field theories, they consider Lorentz invariance regarding relative velocity. But because of discrete structures in loop quantum gravity, it may violate Lorentz invariance according to some criticism. Let us see. So LQG's discrete structure may conflict with high precision experiments of particle physics, which consider Lorentz invariance, and this symmetry is proved in experiments with high precision. In physics, as I told, Lorentz invariance present in all three interactions, that is electromagnetic, strong, weak, strong nuclear and weak nuclear interactions, that relates how two observers moving with respect to each other and perceives physics. Including these three, it is also present in general and special theory of relativity at local level. It means we are talking about local symmetry at small region or small distance. And this kind of symmetry has been tested with high precision. While discrete structure has potential to break this symmetry, we are talking about loop quantum gravity, whose intrinsic nature is continuous, as relative velocity of two observers is a continuous variable. Those who are interested to read this criticism can see my one video regarding length contraction and loop quantum gravity. Here, physicists of loop quantum gravity community have solution of this kind of criticism. They can get rid of this kind of result by some mathematical and technical concept that I have addressed in that video. Also, I will address more on loop quantum gravity with more mathematics and more technicalities in other series of videos. Third criticism is that criticizers tells that Riemann theory doesn't capture dynamics of general theory of relativity. We cannot emerge dynamics of general theory of relativity out of loop quantum gravity according to criticizers. Let us see. But physicists of community prove that it can have dynamics, it can capture dynamics of general theory of relativity by its novel concept, more mathematical concept which are validated, and more technicalities. Though there is no definitive proof because of gap between theory and experiment, and also it is complex. Theoretical formalism of loop quantum gravity is more complex. First thing, and second thing is, we know that loop quantum gravity's units are Planck units. So if you want to prove loop quantum gravity in experiments, you have to apply energy of the order of Planck energy, which is impossible right now, as in Large Hadron Collider of CERN laboratory, which is biggest laboratory on Earth, has reached up to 10 raised to 12 electron volt. So we cannot prove loop quantum gravity using current experimental technologies. So this criticism cannot be perfectly addressed because of technical and technological or lack of technology. Another thing is, once Abdul Salam was asked regarding quantum theory of gravity, that in theories there is no experimental prediction regarding quantum theory of gravity. And Abdul Salam was theoretical physicist. He answered that, how do you know that a theory doesn't have experimental prediction when you don't have theory? It means, first of all, you have to make a theory regarding quantum theory of gravity. Thereafter, you can predict experiment regarding quantum gravity. So this is the address given by this physicist. Thereafter, author tells that our universe is made up of 73% dark energy, 23% dark matter, and 4% visible matter. We only know 4% matter. Though science has been progressing since the beginning of study of science, we could only know 4% structure of universe. Loop quantum gravity, after some times, after few decades, may have answer regarding dark energy and dark matter, and few physicists have been working on these kind of concepts. Our universe is made up of 0.5% stars in this diagram pie chart and 0.3% neutrino and 0.03% heavy elements. So we don't have enough knowledge regarding this 2% or these two category. So in future, physicists of low quantum gravity community may give answers regarding these mysteries of universe using the framework of low quantum gravity. So we don't understand 96% of universe. It means though we have progressed much in science and in physics, we only know 4% of universe. So LQG may answer these all questions and all unsolved mysteries of universe. So in the present video, I complete this lecture series on low quantum gravity for everyone.